Welcome to Business Math. Today happens to be January 22nd. Today we're going to take a look at fractions. One of the interesting parts about fractions is our language that we have. I've studied other cultures in mathematics. In fact, one of the things that I've studied is how the East, namely Japan, China, and so forth, how they, in their language, how their language differs from our language. Because when we say the word 3/4, it really doesn't convey a whole lot of meaning as to what 3/4 really means. I should have a Sharpie, but I don't have a Sharpie either. So I don't know if you'll be able to read this or not, since I can't display on my computer today. But I'll give this a shot on the document key. Okay. When we have I'll zoom way in here. Let's see what we get. When we have a fraction 3/4. That actually means, well, let's see, take a guess as to you tell me what 3/4 means. It's really, we don't talk about it much, so give it your best shot, Courtney and Woodward. What does 3/4 mean?
Almost a full number.
One more time, a little louder.
Almost a full number.
Oh, that's good. I like the answer. It's almost one whole number. Okay. Shay, tell me what 3/4 means.
75%.
Ooh, I like that. I love that, in fact. It's 75%. And tell me what the line actually means, separating the 3 and the 4, Robert.
3 divided by 4.
Excellent. So that means 3 divided by 4. So in fact, if you do that on your handy-dandy calculator, that's how you change a fraction into a decimal. So 3 divided by 4 as a decimal is what, Jonte?
75. 0.75.
Yeah, 0.75, right? It's 0.75. So as a decimal, this is 0.75. Now, what's really, really cool about the Chinese language, about Japanese language, I can't read Chinese or Japanese, but from what I've read, they don't say 3/4. They say, this is the way they say 3/4 in Chinese. Changhao Hua. No, I'm just kidding. No, they say, it translates 3 of 4. 3 of 4. 3 of 4. So it's kind of like you have 4 squares, and 3 of 4 of these is what you're talking about. Okay? 3 of 4. I like that because it conveys meaning. So when they say 1/7, they say 1 of 7. When they say 1/8, they say 1 of 8. So if you take a look at a pizza and you divide that pizza up into 8, 1/8 of a pizza, in Chinese they say 1 of 8. 1 of 8. Now, one of the things that when we add fractions, for example, this should make sense if we need the same size pieces of the pizza. So, for example, when you're going to add 1/4 plus 1/2, well, those are 2 different sizes of pizza pieces. So, for example, there's a half a pizza right there. I realize this is really basic, but you see, if you understand, then when you get lost, you can figure something out. If you're memorizing magic, then you can't stop. You go, oh, let's see. I understand fractions, so let me figure this out. If you're just memorizing magic, you can't do that. Well, when you take 1/4 of a piece of pizza, right here, and you're trying to add to it a half of pizza, you get them the same size. Thus, we have to change 1/2 and get a common denominator. The equivalent of common denominator is the same size of pizza. That's the equivalent of getting a common denominator, getting the same size of pizza. And so we change 1/2 into fourths, and what do you get when you change 1/2 into fourths, Rachel?
It's 2/4.
Very good, 2/4. So now we can change this problem into 1/4 plus 2/4. We have the same size of piece of pizza, so we have one of them, 1/4, plus 2/4 gives us 3/4, using Chinese there, which I thought, wow, I love that, the way they use that in their language. 1/4, because you see the denominator tells you really the size of the piece of pizza, doesn't it? That's what the denominator tells you. So if you have 1/4 plus 2/4, that's equal to 3/4, so 3/4. That's the reason why we have to have common denominator when we add or subtract. We have to have the same size of pizza, same way. If you're going to take 1/2 minus 1/3, if you take 1/2 minus 1/3, you can't do that because we don't have the same size of pizza. So if you draw the pizza again, and if you have a half a pizza here, I realize I'm spending a lot of time on this that's pretty elementary, but it's good for you to understand what's going on. It's not magic. Okay, so you're going to take a half, now you're going to take away 1/3 of a pizza. Well, how in the world do you do that? Well, you got to get the same size of pieces. So the common denominator actually is the equivalent of cutting the pizza so that you got to pretend that all 6 of these pieces are now the same size. You have to pretend that. So in other words, the common denominator is 6. Common denominator is 6. Now in this case, it was pretty easy to figure out the common denominator because 2 is a prime number, 3 is a prime number. Do you remember what the definition of a prime number is, Wyatt? Just in your own words, you don't have to cite the exact definition. But
It's, you can't divide it by anything, I guess. It's, I'm not sure.
You're on the right track. So you get 2 points for your good participation there. You're on the right track. What does it mean to have a prime number, Courtney?
It's not divisible by any other number.
Correct. So it's not equally divisible by any other number other than itself and 1. That's it. So that's a prime number. Well, 2 and 3 are both prime. So if you have 2 prime numbers like that, you just multiply them together, 2 times 3, and that gives you 6. So in other words, change 1/2 so that now you have 6. How many 6 is 1/2? Rachel?
It's 3.
3/6. Very good. And see again how the Chinese language, 1/2 is the same as 3/6. Oh, it's so cool. I read that in one of my many, many books. 1/2 is the same as 3/6. Just like up here now, analogously, 1/3 is the same as how many out of 6, John Tay?
2.
2 is correct. Yes, 2 is correct. So 1/3 is the same as 2/6. Well, now we have the same size pieces, so we can subtract. We have 3 of 6 minus 2 of 6, well, that's 1 of 6. So when you subtract, you get this part left over, which is 1/6 of a piece apiece. But that's the reason why you have to get common denominator, is we're actually getting them the same size. Now, when you multiply, it's no big deal. I'm kind of going over the whole chapter a little bit, giving you the overview of the whole deal here. But when you multiply, you don't need common denominator. Because if I'm saying, I want you to take a half of a third of a pizza. Let's draw a pizza in here. Let's go with a third of a pizza. There's a third. This is a third of a pizza right here, approximately. See, I've had a lot of experience eating pizza, you can tell, right? But there's a third of a pizza, and we want half of that. Well, boom. We just want half. There it is. So we don't need to have a common denominator. We just do 1 times 1 is 1, 2 times 3 is 6, and boom, we get 1/6. We get 1/6 of a pizza. Now, division, on the other hand, is a little more, it's a little trickier, okay? Because when you do division, 1/3 or 1/2 divided by 1/3, you can think of this as a couple of ways. How many, like when you take 8 divided by 2, by the way, this is a fantastic problem-solving method. It's called make the problem easier. If you want to understand a harder problem, look at a related, easier problem. I got to say that again. I got to look right in the camera. If you want to solve a hard problem, look at a related problem that's easier. I got to say that one more time, because this is a 20-year takeaway right here. If you're looking at a hard problem, look at an easier problem that's related. I use that every day, in fact, when I trade stock options. If I want to look at a very, very complex stock options trading strategy, what I will do is I will break it down into easier parts. So if I'm trying to trade a really complex iron condor, I will break that down into a bull put spread and a bear call spread. Doesn't make any sense at all to you. That's not the point. The point is, you take a difficult problem and you break it down into an easier problem. By the way, this next time you drop something on the floor, you drop an earring, you drop a screw, you drop a washer or something, and you're looking for it, take another one of those exact same objects, lay it on the floor. That's an easier problem because you know where you put that one. Now you know what to look for. How many of you ever used that technique? None of you. Well, now you've learned something today. Next time you drop something, like you drop an earring, you drop a screw on the floor, you drop something, and you have no idea where it is, take an item that's identical to that earring or screw or washer or whatever, lay it on the floor, and now look at that. Now you have a picture of what that looks like. That's awesome. It's an awesome problem-solving technique that you need to know the rest of your life. You take a look at an easier problem that's related. And what you do is you keep making the problem easier until you get a solution. Now you get a solution to this real easy problem. We'll try to get a solution to the little harder problem. We'll try to get a solution to the next harder problem, and so forth. All right? When I was taking graduate computer science work down at OSU, the professor said in this graduate course he was going to assign one problem for the entire semester. This is an advanced master's degree level computer science course. He's going to assign one problem, and he told us up front, nobody in the entire world has ever solved this problem. So right there, 8 students just headed to the door and dropped. No, I'm kidding. This is a graduate class. So what in the world do you think I did to try to solve that problem? We had an entire semester. Nobody solved this problem in the entire world. Tell me what I did. Let's go back to Courtney. Courtney?
You found
What's that?
an easier problem. You found an easier problem?
Yes, I said, you know, this problem is related to this one. It's easier. It's easier, but it's related. So I found a solution for this. And I wrote the computer program that would solve this problem that was related to this one. And then I said, you know what, let's make it a little harder. So I said, now let's see if I can solve this problem. And so I solved this problem. That was a little harder than the first problem I solved, but it's still related, and it's getting closer to this really hard problem that I solved. And then the next thing I did is I solved the third problem that was harder than the first two problems, and I solved that. And then I did the fourth problem that was harder than the first three, and then I solved the fifth problem that was harder than the first four. And do you think I was the first person on the planet to solve this problem that no one has ever solved before? Robert, do you think I was the first person to solve it?
No.
No. Sounds good. Robert, you blew your chance for extra credit. I was going to give you 8,000 points of extra credit for believing in me. But, Robert, you gave the right answer, so I should give you the 8,000 points, shouldn't I? I didn't get the final answer. I don't think anybody in the class did. I don't think anybody in the whole graduate class did. But I had 5 problems with solutions to hand in at the end of the semester. Now, this young kid sitting next to me as the professor was passing out the final exam, and we all passed in all of our computer code and the whole bit, and he told the professor, he said, sir, I don't have anything to hand in. And the professor just looked at him like, okay, you've been working on this problem, supposedly, the whole semester, and you have nothing to hand in? And he goes, well, I couldn't get anything to work. Ouch! Do you get the point? This is 20-year takeaway. I realize it's in the morning, and I realize that none of us are awake hardly, and it's rough. This is way more important than fractions, let me tell you, folks. I want you to take this 20-year takeaway, so 20 years from now, when I'm 84 years old and I run into you at some business, by the way, this happens occasionally. I ran into a student that I had 20 years ago at Weimer Brownlee, and she says, you know that math class I took from you? I still use some of those problem-solving strategies. And this is a big one. Make the problem easier. Make the problem easier. That's huge. All right, did you get it? I hope so. So what major problem strategy did I teach you today, Robert?
Make the problem easier.
Make the problem easier. Boy, that's something. I could go on and on about changing my wife's, don't get ahead of me now, changing my wife's shock absorbers on her car. I'd never done that before in my life, and that was a problem, right? But I took my problem-solving techniques, and I said, let's see if we can make the problem easier. I couldn't get the bolts loose. I said, well, let's make the problem easier. Let's squirt some good old, penetrating oil on those nuts and let those sit. See if that can loosen those nuts. Trying to make the problem easier. That didn't work. Very well, shoot, I'll just take my grinder and I'll just cut the bolt off. I'll make the problem easier. Then I won't even have to try to use muscle to undo the bolt. So I just cut the bolts off. But the point is, I use that problem-solving technique, especially now that I'm in finance and with stock options trading and so forth. I make the problem easier. You better remember that one. See, I have these questions, but when you're lined up for graduation, see, you're all lined up for graduation. And then Courtney, I'm going to sneak up right beside you, and I'm going to go, Courtney, name me a very, very, very important problem-solving technique. And if you can't say, make the problem easier, I'm just going to order security to grab you right out of the line and say, don't let Courtney graduate. No, we don't do that, but we should. We should have certain questions that, anyway. Well, division, make the problem easier. This problem right here, I think you will agree, 8 divided by 2 is easier than 1/2 divided by 1/3. This, a division problem, what we're really saying is, how many 2's are there in 8? Well, the answer is 4. The question here is a little harder, but how many 3rds are there in 1/2? That's a harder question. Another thing that you should know is that 8 divided by 2 is the same as, these are inverse operations, it's the same as 8 times 1/2. So 8 divided by 2 is the same as 8 times 1/2. So in fact, if you want to change this to a multiplication problem, you can change it by taking 1/2 times what? Wyatt. Now Wyatt, not Rachel.
Trying to get to 8.
I'm trying to figure out 1/2 times, or 1/2 divided by 1/3 is the same as 1/2 times what? Just keep in mind that division and multiplication are inverse operations. So I want the multiplicative inverse of 1/3, don't I? What is the multiplicative inverse of 1/3?
3.
It's 3 over 1. Thank you, Rachel. Very good. All right. I just love high def mics. I just love it. We're having more fun than a human being should be allowed to have, right? So 1 times 3 is 3, 2 times 1 is 2, you get 3/2. And 3/2, if you want to change that into a mixed number, what is 3/2 as a mixed number, Shay? What's 3/2 as a mixed number?
1/2. 1 and 1/2.
1 and 1/2. Very good. See, 3/2 is the same thing as 1 1/2. Now, hopefully, you know how to change mixed numbers, 3 3/4, into an improper fraction. There's 3 3/4. Now, do you remember how to change that into an improper fraction? Let's see, Courtney, do you remember how to do that? Change that into an improper fraction?
Multiply.
Correct. So we take 3 times 4, that's 12. In other words, see what we're really doing on 3? Here's what's visually going on. We have 3 pizzas right here, okay? We're going to cut these up into quarters. We're going to cut these up into quarters. That's what 3 times 4 means. Now we have 12 of these pieces of pizza, plus the 3 of 4 right in here. So that makes 15 of these quarter-sized pieces of pizza. Now that might be the first time in your life that you really know why we do 4 times 3. The reason we do 4 times 3, we're changing this whole number into quarter-sized pieces of pizza. That's really what's going on. It's not magic. We're changing them all into quarter-sized pieces. So now we have 12 pieces of pizza that are all the same size, quarters. And then we add 3 more to that, so we get 15. So that's our 15 quarters. So what's really going on is we change this into 12 quarters plus 3 quarters, and that's how we got 15 quarters. All right? Now, of course, to change that the other way, 15 quarters, to change that into a mixed fraction, mixed numeral here. So we go 4 and a 15. It goes 3 times. That's 12. There's 3 left over. So the answer is 3, and there's the remainder. That goes in the numerator over the divisor, which is 4. So that's where we get our 3 3/4. Hopefully that's all review. Now, let's see if there's any other good stuff in your chapter here. All right, we talked about prime numbers. Hopefully you have your book, because I don't know if I can get a hold of chapter 2 of the PDF. A lot of times what they'll do is they'll just let you have like the first chapter, because they figured by the end of the first chapter everybody should have their book. So, let's see some terms. Numerator, denominator. This is real basic, but I'll ask it anyway. What part of the fraction is called the numerator, Wyatt?
The top.
Very
Top
good.
number.
Yep, the top number. And the bottom number is called what, Jonte?
The denominator.
Very good, the denominator. That's easy enough. Then you have proper fractions. This time on page 39, if you're following along here. Oh, that would be awesome. Let's see, because I see most of you have your book. If you don't have your book, you might slide close to somebody that does. But anyway. In fact, Rachel, you can take a peek with Wyatt's permission, of course. On the top of page 39, we have proper fractions. Okay? Rachel, tell me what a proper fraction is. What is a proper fraction?
It has a value less than 1.
Bingo! It has a value less than 1. So 3/4. That is a proper fraction. Okay? An improper fraction. What's that, Shay?
It has a value equal or greater than 1.
Very good. So in other words, like 14 over 14, that's an improper fraction. Okay? Mixed numbers. Tell me what a mixed number is, Courtney.
The sum of a whole number greater than 0 and a proper fraction.
Bingo, there you go. So, life is good. More fun than a human being should be allowed to have, right? So, then your author goes over the conversion of improper fractions to whole and vice versa, kind of like I did. Then your author goes over a couple things. Finding the greatest common divisor. Greatest common divisor. In other words, it's like finding a... You need to learn how to find a common denominator. You want me to try the computer now and see if it works?
No.
But I'll be done in a few minutes. And then
Just wait till you're done.
Yeah, because it's working. I've been using the document can. And the recording appears like it's working fine. So. But anyway, you need to be able to find a common denominator. And you need to be able to find the least common denominator. We went over that. Let's go over a method again for least common denominator. And let's pick something pretty dang hard, okay? Let's pick something pretty hard. Least common denominator. We're going to add a couple of real weird fractions, okay? We're going to add 3/14 plus 7/60. Okay? That's pretty weird. 3/14 plus 7/60, and we want to get the least common denominator. Now, if you remember, the first thing you do is break this down into a product of primes. So 14, break that down into a product of primes. All right, 14, what is that as a product of primes?
It's 2 and 7.
Oh, excellent, Rachel. 2 and 7. So 2 times 7, and both of those are prime. So we're done. Now, over here, if it takes you a while to use this is actually called a factor tree. If it takes you a while, you go, okay, that's 2 times 30. And are we done there, Wyatt? 2 times 30?
No, you have to break down 30.
Right, because 30 is not prime. So, yeah, okay, 2 times 15. So are we done now, Robert?
Sure.
Sure. Let's just go have donuts and coffee, right? What do you think, Courtney? Are we done? No, we're not done yet, are we? Because 15 is not prime. So, Shay, we got to break 15 down into what times what?
3 times 5.
Very good. Now we've got it. It's 2 times 2 times 3 times 5. So this 60, the product of primes is 2 times 2 times 3 times 5. The product of primes over here is 2 times 7. So to get the least common denominator, let's see, we need a 2. So we'll put a 2 over here. We need a 7. Got to have a 7 in our least common denominator. Well, let's see. Oops, we need 2 2s, don't we? So we got to throw in another 2 because for 60, it has 2 factors of 2 in it. Then, let's see, we do need a factor of 3. And then we also need a factor of 5. So our final answer will be 2 times 7 times 2 times 3 times 5. That will be the common denominator for 14 and 60. All right? So let's see, we don't have much time left, so let's keep moving. But that's very important. And the important part about that is that when we're getting the least common denominator, we're cutting the pieces of pizza into the same size. So then now we can add because we have the same size pizzas, or the same size pieces of pizza, all right? That's the reason why we get the common denominator. Well, on your practice quiz on page 41, this is just like usual now. So by Wednesday, you'll have this assignment due, the practice quiz. I don't know if I have it posted yet for you live students. For you online students, it should be posted by now. As well as hopefully online students, you've already taken your quiz over Chapter 1. And I think I already said this. I can't remember if I put it on the recording. I'm going to give you 3 tries on the quiz. Now, the quiz comes from a large number of questions from a test bank. So each time you take the quiz, you're going to get different problems. But I'll give you 3 tries to get all those right. Now, it's not going to, it'll tell you the score. But that's all, I think that's all it'll, well, I'm not sure. I probably already told you, did I tell you I was going to tell you what the right answers were? I think I will. I'll tell you what the right answers are, okay? It's very important in math. If you don't understand why something went wrong, you're going to have a tough time fixing it, right? It's like when I trade stock options and something goes wrong, I better know how to fix it. So that next time, it's not going to go horribly wrong. Like I already told you, August of 2011, I lost $160,000 in 1 month trading stock options. Well, hopefully I figured out what was wrong, so hopefully that's never going to happen again. That was real money, by the way. That wasn't plain money or anything else. So the key to learning is when you make a mistake, you figure out what you did wrong. By the way, one of the best gifts that you can give your children is to separate their performance from their value as a person. See, failure is an event. It's not a person. That's Zig Ziglar. Failure is an event, not a person. My mom did a great job separating my performance from my value as a person. So consequently, I was never afraid to try things. In fact, it's probably her fault I lost $160,000 in 1 month, right? No, I'm not blaming her. It was my decision. I did it. It was all me. The point is, however, if you can separate performance from your value as a person, all right? Just so if you make a mistake. So I'll tell you what the right answers are. I'll go ahead and do that. And if I forget to do that, shoot me an email or call me, okay? Now, last couple minutes, I want to go over, these are already 3 books that I gave out for extra credit because they're related to problem solving. These books are related to problem solving. Okay? Here are the books that I've given you so far that are related to problem solving. Number 1 is the one by George Polya, it's How to Solve It. Okay? Great classic problem-solving book. Don't get too lost in the details. That's How to Solve It by George Polya. The second one is a great problem-solving book because it had probably the greatest problem-solving habit of highly effective people is start with the end in mind. See, I gave you that one before. Start with the end in mind. Huge problem-solving strategy. What was the problem-solving strategy I gave you today, Courtney?
When you have a hard problem, find an easier problem that relates to it.
Bingo! Make the problem easier. So that's a great problem-solving strategy. In fact, I should bring Mike in here sometime and have him share some of his great problem-solving strategy. He's our IT person. He does a lot of problem-solving for us. So 7 Habits of Highly Effective People, and then later on in the course we're going to do some statistics, and there's a great book, I can't remember who the author is, of How to Lie with Statistics. These are 20 points. I'm sorry?
Okay, see the pink cards.
Okay, well let me zoom in tighter here. Okay, let's go right there. So the first one is How to Solve It. Okay, that's the first one. And the second one is 7 Habits of Highly Effective People. And the third one is How to Lie with Statistics. Okay? So those are your 3 extra credit books so far. Well, anyway, that's all the time we have for today. You guys did a great job. Call me if you have any problems. If you don't understand why you got something wrong on one of your quizzes, or if you're having trouble with your homework or anything else, let me know, because your next assignment is going to be the practice quiz, page 41 and 42, as well as the extra practice quiz on the middle of page 42. Don't forget, you just take a picture of your homework. That's how you hand it in at Blackboard. You just attach the picture. If it takes multiple pictures, then you zip those together. If you need some help with zipping files together, you might have to go to the Academic Success Center. I think probably somebody up at Ponca knows how to zip files, in case the 2 of you have any trouble. Have a great day, and I will see you Wednesday.